Okay, now we are going to solve number 6c, which says, is the state described in the table below safe or unsafe? So we are going straight to the point because we don't have much time. So this is the question. So this is our claim matrix, which is represented as C, our allocation matrix as A, and the need. This is also known as need. So the need is matrix C minus A. So next step to do is to check our need, which is C minus A, and look at available vector, which is 1 unit of resource 1 and 1 unit of resource 2. So we are going to check the needs and see the process that can be executed. So if we look at the processes, only process 2 can be executed, which is in need of 1 unit of resource 1 and 1 unit of resource 2. So next step is to write same matrix, but we assume process 2 has finished execution. So we will replace process 2 with 0. So here we have process 1, process 2, process 3, and process 4. So we replace what is here, but process 2 will be 0. So here we have 4, 2, 0, 0. We have 1, 3, 3, and 2. Here we have process 1, process 2, process 3, and process 4. So here we have 1, 2, 0, 0, 1, 0, and 2, 0. We copy same thing here, but we replace process 2 with 0 because it has finished execution. So the next one too, we put process 1, process 2, process 3, and process 4. So here we have 3, 0. Because process 2 have finished execution, we replace it with 0, 0. Here we have 0, 3. We have 1, 2. So always resource vector is constant, it doesn't change. So to get our available vector, we are to add the allocated unit for process 2 which have been executed to our resource our available vector. That is, here we have 0 plus 1, then here we have 1, and for resource 2 we have 1 plus 1, here we have 2. So now our available vector is 1 unit of resource 1. Okay, now we have calculated our available resource. So next we are going to check our available resource and compare it to the need vector, which is process 1 cannot be executed because we have only 1 unit of resource 1 and it is in need of 3 units. So we go further. Process 3 also cannot be executed because we have 2 units of resource 2. Next process that can be executed is process 4. So if process 4 is executed, we assume it has finished and leave the system. So next we are going to write this same vector here, matrix here, and substitute process 4 with 0. So here we have process 1, 2, 3, and 4. Here we have 4, 2, 0, 0, 1, 3, 0, 0. And here we have 1, 2, 0, 0, 1, 0, and 0, 0. Here we have process 1, process 2, process 3, and process 4. Here also we have process 1, process 2, process 3, and process 4. We still copy what's here, but we substitute process 4 with 0. Here we have 3, 0, 0, 0, 0, 3, 0, 0. So here we say our resource vector is always constant. We have 5, 4, and our available vector. To calculate our available vector for this, we add the process, the units given to the process executed, the previous process executed. Here is process 4, so we add the 2 units allocated to process 4 to our available vector. Here we have 2 plus 1, here is 3, and here is 0 plus 2, here we have 2. So next we check again our available vector and compare it to our need vector. Here process 1 can be executed, so process 1 will be assume that it's finished its execution and left the system. Here we have P1, P2, P3, and P4. So we substitute process 1 with 0. Here we have 0, 0, 0, 0, 1, 3, 0, 0. So the next, which is our allocation vector, will be P1, P2, P3, and P4. Here we have 0, 0, 0, 0, 1, 0, 0, 0. And next, next, which is our need vector, we have P1, P2, P3, and P4. Here we have 0, 0. Since process 1 have finished execution, we have 0, 0, 0, 3, 0, 0. So here we have our resource vector, which is 5, 4, and our available vector will be the previous process that has been executed, which is process 1. So we have 1 plus 3, which is 4. So here will be 4, and this resource 2, we have 2 plus 2, which is 4. So here our available vector is 4 units of resource 1 and 4 units of resource 2. So we compare it again with our need vector, and our need vector, we have only one process that's waiting, and it is in need of 0 unit of resource 1 and 3 unit of resource 2. So when process 3 is executed and left the system, here we have everything will be 0. So P1, P2, P3, and P4 all will be 0. So here we have P1, P2, P3, P4. We have 0, 0, 0, 0, 0, 0, 0, 0. P1, P2, P3, and P4. Also we have 0, 0, 0, 0, 0, 0, and 0, 0. So here our resource vector is we have R1, R2, which is 5, 5, it doesn't change. 5, 4, it doesn't change. So our available vector now will be equal to our resource vector, which means there is no allocation, there is no unit that is allocated to a process. So here we add the previous as usual. Process 3 is the one that have been executed, so we add 1 plus 4. Here is 5, then here 0 plus 4, we have 4. So as we can see, the resource vector and the available vector is equal. That means we haven't allocate any unit of the resource vector to a process. So this means that the state we are seeing here in the question is safe, because all the processes has been executed successfully. So thank you.